In today's video, I'm going to talk to you about a new HPE InfoSight feature called Resource Planner. Resource Planner helps to determine optimal workload placement based on simulated impact to array resources, specifically cache, capacity, and CPU. You're able to predict resource needs using the tool's easy-to-use drop-down menus and checkboxes. This feature will be available for HPE Nimble Storage and will be posted in the lab section of the InfoSight portal. The Array Information tab gives you an overview of all HPE Nimble storage arrays which are registered to this InfoSight account. For this first demo, I'm going to add one new workload. This adds one new default application workload for us to work with, and unless it happens to be exactly what you're looking for, you'll need to modify it and customize. Now I'm going to name this appropriately and then select the application category. This category is based on volume performance policies, which are configured on the HPE Nimble storage arrays. By analyzing similar workloads across many customer environments, we've been able to identify certain cause and effect relationships. For instance, we know what effect deduplication has on CPU usage across different array models. We know that virtual desktop environments are more easily deduped and compressed as compared to SQL. Using this type of determination, we can easily simulate changes to predict future needs for a specific set of arrays. You can also make other changes to the new workload as needed, such as toggling dedupe on and off and configuring max IOPS. I'll save those changes and you can see that the workload details have been updated. Next, I'll choose the array I want to model this workload on. I'm going to check the Display Multiple Arrays If Needed box, which I'll talk about later. Hit Analyze and wait for the results. The Resource Planner app is taking advantage of the AI and machine learning back-end systems, which is the real magic of InfoSight. What we see are the effects of this new proposed application workload on top of what the array is already doing, for CPU and capacity resources in this case. If this was a hybrid flash array, we would also see the effects on cache, but this particular array is an AF60, so we don't see cache. What we do see is that we will have enough CPU and capacity resources to run the new workload. But we'll need two AF60s to do that according to the top graph. But it looks like one AF80 will do the job if we wanted to run it on just one. The capacity section is color-coded with the new workload in black and the existing current workload shown in blue. Now I'm going to uncheck the Display Multiple Arrays box and see what happens. You can see the top chart change, now showing us a status of impacted. We can see the AF60 we're modeling this on will not have enough CPU resources to handle the new workload, plus the one it's already running. I've added an application which has the default settings. I'll modify it, choosing a new SQL workload this time. So now we'll see if this array can adequately handle a new 10 terabyte VDI workload and a new 20 terabyte SQL workload on top of what it's already doing. System status is impacted as far as CPU goes, but still okay for capacity. The tool is estimating CPU usage to be around 137%. All of the models within a certain family are shown for comparison, and we can see again that the AF80 will handle the proposed workloads. In the chart below, you can see the breakout of capacity usage per application. Now let's check the Multiple Arrays box and see what that does. It looks like if you wanted to run these two new applications on top of the current workload and you wanted to use AF60s, you could do that, but you would need two heads. With Resource Planner, you also have the option of modifying only the current running workload on any given array. In this case, I've selected Add Existing Workload from the first section, and then I'll hit Modify to make changes. I'm going to give this an appropriate name and then select the array pool I want to play with. You can select which object you want to edit, and in this case, I'm choosing to look at only file server applications. Just like we saw before, these are based on the HPE Nimble Storage volume performance policies. You can also aggregate by volumes, volume collections, or folders. We then select a date range for the analysis, and in this case, I just took the default. I'm going to see what will happen if only the file server workload doubles in overall workload and capacity. In many cases, only certain applications or environments are expected to grow. This allows for very granular control of what you're modeling instead of taking the aggregated overall workload of the entire array. In this case, it looks like the array will not be impacted regarding CPU and capacity resources. As you can see, I've got the multiple arrays options selected. And here's what it looks like when we uncheck that. In future releases, we hope to have this option available for showing multiples in regards to capacity as well, but for now, this is only a CPU section. Now I'm going to go back in and add two different application objects. In this case, we'll check the effects on array resources if both the file server and the VDI application workloads double. In this case, CPU resources will be affected on this AF60 as the top chart shows. I'll go ahead and check the Display Multiples option and view the results. For this next demo, I'm going to add a new application to another array in our test environment so you can see some different models. In this case, I'm going to simulate running a new 25 terabyte Oracle application with a sustained workload characteristic. The array I chose is a hybrid flash array. This means we'll be able to see what effect this new workload will have on cache as well as CPU and capacity. The orange color shows us we're right on the border at 86%, but still below 100% CPU utilization. On the bottom chart, you can see cache needs split out. Cache needed for performance in black and cache for dedupe shown in blue. I'm going to go in and change the workload characteristics to see what might happen. I'll just change workload to bursty instead of sustained. Then hit Analyze to rerun the modeling process. Our HF20 is now shown in red, meaning it will not be able to deliver adequate resources for the new application with the workload selections we made. The top chart has a status of impacted, and the predicted CPU utilization is over 100%. Capacity and cache status are still showing not impacted. I'll go ahead and check the Display Multiples option and view the results. Well, I hope you've enjoyed this brief overview of Resource Planner. As I mentioned before, this will be available for HPE Nimble storage arrays and will be posted in the Lab section of the InfoSight web portal. Thank you, and goodbye.